Okay, so this is our short review of the Gprs environment to help you remember what we talked about in class and to be sure that you understand all of the different parts so that when you go to do your mapping exercise and your different work, you'll be familiar with the terminology. So to begin with, this is the basic architecture for a Gprs environment. The customer will be here in the field, where their handset will hook up to the tower, the cell, down to the BTS, and to the BSC, just like any other call. However, in this case, instead of the call being routed to the MSC, which would normally be the case, we now route our request for data packets to the SGSN, the serving gateway node, through an internal Gprs IP cloud, the GGSN, which is the gateway node, which then attaches to the public internet through what's called an APN. So the key elements here are SGSN, GGSN, external internet cloud, internal internet cloud, and the radio network, the cell, the BTS, the BSC, and the PCU, which is the packet communication unit, which turns the radio signal into packets so that it can be fed into the network. So your exercise is going to be to prepare an inventory of all of the components to make sure that you understand what all the parts of the system are. So again, here's our basic environment. You're going to want to talk to the network engineers about how many SGSNs do we have, how many GGSNs do we have, how are they connected together, how many BTSs, how many BSCs, and how do they hook up to the SGSN. The billing architecture for Gprs is very similar to that for voice. We have our BTS, our BSC, and our PCU. The PCU is sending the packets to the SGSN and then through the GGSN. In this case, both the SGSN and the GGSN create a thing called an SCDR and a GCDR. These are CDRs pretty similar to those created by circuit switches, only this time they contain data information. They are sent to the mediation system, where they're then combined and put together into single CDRs and then forwarded to the postpaid billing system. And many of you will also forward them to the data warehouse for communication and for analysis. Now, I have sent you all an article written by a consultant who wrote the article for billing and OSS systems. It talks about the different Gprs CDRs, what they're about, where they come from, and how they're configured. So please read that article as part of doing this assignment. When it comes to AAA for Gprs, we're going to see that that also is similar to voice, but with some big differences. In this case, both the SGSN and the GGSN are going to have to go through a AAA sequence. The process of a handset asking for authorization is called PDP attach sequence. And the PDP attach sequence is actually just the IP address assignment sequence. So the customer turns on the handset sends a PDP attach request. It's forwarded to the SGSN. The SGSN will then authenticate against the HLR and the AUC and authorize, just like a switch does. And it will then store that information in its own version of a VLR. Different manufacturers have different names for this unit, but it's a place in memory where the SGSN keeps track of the customer and what he's authorized to do. After the PDP attach is successful with the SGSN, the GGSN will also be asked to do a PDP attach. It will also check the HLR and the AUC, and it will then, most critically, get an IP address assigned. Now, there are several different ways that that can happen, either directly written from the HLR, through a DHCP server, through a radius server. It's important that you find out which one of those methods is used, and the IP address is assigned by the GGSN to the handset, along with a CID, a charging ID. The charging ID is similar to a CDR serial number. It's the number that ties all of the CDRs across the system together so that we can put together one event for the customer. Finally, when we're doing prepaid billing for GPRS, again, the packet requests and the packet data moves through the SGSN and the GGSN. In this case, the GGSN and SGSN both communicate with the IN prepaid billing system. In the GPRS world, these are called billing gateways. Now, there are fundamentally three different ways that people can be authorized to use services. They can be billed by volume, which is quoted by a certain number of megabytes, time, a certain number of minutes, or bandwidth, which will be a certain amount of volume per a certain amount of time. So I may be authorized for 500 megabytes of data. I may be authorized to run for 1 day, or I may be authorized to get 256 kilobytes per second. Whichever combination of these rules is involved in the billing, the SGSN will do a polling request just like a switch requests a prepaid billing system. If it's doing a volume-based billing, it will come back and say, billing system, is this customer authorized for the next 100 megabytes, yes or no? And it will pass back the yes-no message. The SGSN will then keep track, and when it runs out of credit, it will come back and ask for the next increment. In the same way, the GGSN can ask the same kinds of questions. Now, whether the billing is managed by the SGSN, the GGSN, or a combination of both is completely configured based upon the business rules and set up by the network engineers. So when you're doing prepaid billing verification and assurance, you need to be finding out what the different billing methods are and which one of these systems is responsible for communicating with the IN. The other thing we need to be looking at when we're getting an assessment of that environment is understanding how this environment hooks up to the outside world. Generally, there are three interfaces out of the core GPRS network into the rest of the world. On the one hand is the internal connection, the internal packet network, where we hook up to our radius servers, our security servers, and the other environments in our IP environment. The other connection to the outside world is the hookup to the outside internet for partners. That hookup will be handled by a border gateway router, and that will hook up to the public internet. Those IP addresses will be provided to the partners, and the partners can get in here and access data through the GGSN. And finally, of course, the APNs, which come out of the GGSN and hook up through our firewall to our other systems. Each of the manufacturers of SGSNs and GGSNs has a unique configuration, so you're going to have to talk to the network engineers and get the documentation for your particular vendor to verify the exact details of how this works. This is a diagram of the Nokia Siemens GPRS environment, and as you can see, both their SGSN and GGSN communicate with their charging gateway using the GTP prime protocol in order to do the polling that we talked about. They also have a hookup to a border gateway for their hookup to their IP network partners, and the GGSN hooking up via an APN to the internet. This is a network diagram that somebody put together for their own environment to kind of give you an understanding of what we'd like to see when you do your own network mapping. You can see I've illustrated the BTSs, the BSCs, the internal cloud, the external cloud, and the different APNs. The job of the network revenue assurance person is to make sure that all of these different connections are in place and secure. And the first job, of course, is to put together a map like this for your own environment. So good luck with this assignment, and we'll be talking to you again soon.